Okay, we're doing some work on fractions, and you're looking at this crazy man who's got bits of paper here all folded up, and I want to have a look and talk about equivalence today. These bits of paper have been folded in quarters and they all look very different, so but they are the same amount. Alright, and that's this idea of equivalence being equal. And for some of you, it might be seeing that equal sign in the middle between a couple of fractions, and today understanding a little bit more about what that sign means. And also, what we'll do is we'll focus in and look at the numerator and the denominator and see if they have any common factors. And if they have some common factors, we can simplify that fraction and create an equivalent fraction that's smaller. Well, it's not smaller because it's the same, but the numbers that we're dealing with are smaller, and hopefully that makes it easier for us to work with. So I'm going to jump behind the lightboard and show you some of those things and some of those ideas, and hopefully today we can really embed this knowledge. We're working on fractions, and there's another key idea, key skill here, and that's this idea of equivalence, things being the same. Okay, so the same quantity, if you like. Okay, so let's explore that idea. And I've got a set of scales over here because I see the equal sign as if we have the same quantity in each of these baskets on a set of scales balances like this, this bar should be level. So let's just explore that with a couple of questions. So if I had a half, that's if I double all these numbers or times it by 2, that's equal or equivalent to 2 over 4, which is the same thing as 4 over 8. And if I keep doubling these numbers here on the numerator and the denominator, I end up with 8 over 16. Okay, we can simplify those fractions, and I'll show you that in a moment, and we will get back to a half. Okay, so if they're not equivalent, so let's do one example what would throw this set of scales off. Say I had a half, and for some reason that I thought it was equal to 3/4. Okay, clearly they're not, and you can use this sign, just a simple stroke of the pen. I've changed that sign in from an equal sign or equivalent to being not equal to. Okay, simple. That's what that symbol's designed for, is that if you see that they're not equal, you can just put a line through the equal sign and make that statement true. So now when I read it as a half is not equal to 3/4. Okay, so visually, if you needed it, there's a half and here's 3/4. They're not equal. All right, so let's just try. In essence, what we did here was multiply things by 2. We just doubled them. Okay, we can create equivalent fractions. Let's try 3 over 5, and this time let's multiply the numerator and the denominator by 3, so we get 9 over 15. And let's keep that pattern going. So 9 times 3 is 27 over 45. And we could continue on with that pattern. So they're equivalent, they're the same, because eventually they will simplify to what we started with, 3 over 5. So there's a couple here. Now I need to talk to you about simplifying fractions, and I've got a couple of examples here. You'll see this word, simplify. Let's try this example, 16 over 20. Now this really depends on what you see. One way we could set this out, I see they're both even numbers, and so 2 is a common factor, so I could change this to halve each of those numbers, 8 over 10. They're both still even numbers, so I could halve them again to get 4 over 5. Okay? I could do this question a different way. If I had 16 over 20, I might run out of room there. So let's move that over here just in a different color. 16 over 20. Now I can see that is 4 times 4, and I can see this is 4 times 5. So set up this way, we can cancel the 4's, and what are we left with? We're left with this portion here, which is equal to 4 over 5. That's one way to represent it. Okay. Finally, I'll just write it a little bit bigger over here, 16 over 20. When we understand that and we get good at thinking this way, what I tend to do is if I see 4 as the highest common factor, and I often don't write this, HCF meaning highest common factor, what I do say is 4 goes into 16 4 times, and 4 goes into 25 times. And if I do a nice neat job of this, then I just rewrite my new fraction as 4 over 5. Now, the thing to understand is that these numbers are equivalent. Okay? They're representing the same amount.